Namaste. Myself JV'N Gaurav from the discipline of radiology in the diagnosis. I am in the Department of Diagnostic and Community Health from the Faculty of Physiotherapy and Diagnostics, JV'N Women's University. Today we are going to discuss a session that is very useful for or to understand the general radiation physics setting or the physics behind the X-ray production, the X-ray tube or the surrounding, and about the radiographic techniques of whole world. Namaste. In today's session, we will discuss about the anode angle. Anode angle is defined as the angle of the target surface to the central axis of the X-ray tube output port. Means it is the angle between the target surface and the central axis of the cathode of the X-ray tube. Okay, diagnostic X-ray tube have angle between 20 degree and 60 degree and 12 degree to 15 degree. Means 6 to 20 degree angle are 12 degree to 15 degree angles are commonly used. The optimum choice of anode angle depends on the clinical uses. A small anode angle 6 degree is used for special techniques such as angiography equipment, in which X-ray field coverage is limited by the image intensifier diameter. Okay, in which the X-ray field coverage is limited by the image intensifier. Okay, large anode angle are necessary for general radiographic work to achieve large field area at short focus to film distance. Okay, so the large anode angles are necessary for general radiographic work to achieve large field area at short FFD, for focal to film distance. Okay, so this is the anode angle. Anode angle depends on the clinical usage, or it varies from 6 degree to 20 degree. For large area or small FFD, the large anode angle are used. Okay. In today's session, we will discuss about the stationary anode X-ray tube. The modern X-ray tubes are based on the Coolidge X-ray tube, or the modern X-ray tubes are two types: stationary or rotating anode X-ray tube. The stationary anode X-ray tube, in which the anode remains stationary in or during the operation. Okay, stationary anode X-ray tubes, in earlier period of time, gas tubes were used to produce X-ray. In earlier period of time, gas tubes were used to produce X-rays, but these tubes suffered with some disadvantage. Hence, Coolidge scientists proposed a prototype X-ray tube based on the thermionic emission principle. Okay, On the basis of Coolidge tubes, several X-ray tubes have been designed. The stationary anode X-ray tube is one of the modern X-ray tubes in which the anode is stationary. Okay, so it is a modern anode, modern X-ray tubes, or the tubes are based on the thermionic emission principle. Means the emission of electron after exciting the filament of cathode. The stationary anode X-ray tube consists of a cathode and an anode, which are kept in an evacuated glass bulb made up of Pyrex glass. The cathode consists of tungsten filament in the form of coils placed in a shallow focusing cup. The filament is made up of tungsten wires about 0.2 mm diameter that is coiled to form a vertical spiral of about 0.2 meter in diameter and 1 centimeter in length. Means the filament is in the form of spiral or wire. The filament is heated by passing an electrical current through it from a low voltage supply. So this is the stationary anode X-ray tube. The components are the same for stationary anode X-ray tube, gas tube, or rotating anode X-ray tube. The basic components are same, like cathode, anode, focusing cup, or envelope, or housing. These are same, but materials that is using to make these components are different. In the gas X-ray tube, the cathode is made up of aluminum, okay, and the anode is made up of platinum baked in copper. Okay, or in the stationary anode X-ray tube, the cathode is made up of tungsten material, or the anode is made up of tungsten disc in the form of tungsten disc in the copper block. So these are different. Okay, and the principle of modern and gas X-ray tube are different. Gas X-ray tubes are based on the ionization of gases in the X-ray tube, and the stationary or rotating anode X-ray tube is based on the thermionic emission principle. Okay, thank you. In today's session, we will discuss about the X-ray tube insert and housing. So housing means protection from any type of exposure, unnecessary radiation, for longevity of the X-ray tube. So tube insert and housing protect the X-ray tube from the long exposure. Okay. The X-ray tube insert consists of cathode, anode, rotor assembly, and support structure. So X-ray tube insert consists of cathode, anode, rotor assembly, and supporting structure. Rotor assembly rotates the anode with the help of motor or bearing. Okay, and support structure like stand. Okay, sealed in glass or metal enclosure. That is a metal enclosure. That is a house. A high vacuum is required within the insert to ensure that electron traveling from the cathode from the cathode do not collide with gas molecule. Do not collide with gas molecule as X-ray A gas molecule as X-ray ages means X-ray occur or get older, then gas molecules trapped in the component are released. This reduces the integrity of the vacuum. Most X-ray tubes provide a better circuit to remove gas molecules. The port through which X-rays emerge is the X-ray window. X-ray window. The window is usually made of the same material of the tube, except in mammography, which use beryllium window. So, mammographic X-ray tube uses a beryllium window as a window material. The X-ray tube housing. The tube housing support, insulates and protects the tube insert from the environment, from the bombarding of electrons, from the unnecessary radiation protection, and it also insulates from the any electrical spark and support the X-ray tube. Surrounding the tube insert, special oil is provided which helps heat conduction and electrical insulation. So the oil surrounding the tube insert helps in heat conduction and electrical insulation. Many X-ray tube housings contain bellows. As the oil expands excessively, the bellow activity are microswitch so that the further use of tube is prevented. Okay. So in this session we can discuss about the tube insert and housing. Tube insert means the component that is present in the X-ray tube. Housing includes the protection, insulation, and support of the X-ray tube. So, housing insulates from the electrical conduction and protects from any type of bombardment, any type of unnecessary interaction, or the product of the interaction. So these are the insert and housing are necessary for a X-ray tube conduction or operation. Okay, thank you. I hope you all understand better about better understood the insert or housing, or you will get good knowledge about the tube insert and housing and their work in the X-ray tube. Thank you. Thank you. The session is over. I think you are satisfied with this session that we had discussed in today's class or today's lecture. If you have any query, then put it into the comment box. I will resolve it later. This session is powered by digital version 2.0, JV'N Women's University, Jaipur. Thank you.